Hey, I'm back again from my flat in Berlin, trying to keep in the aviation game as I take my summer vacation from instructing. And I've been writing things in my notebook here, which those of you who have seen my videos before would recognize. One of the things that I did when I was training for my CPL license, I noticed that as I was going through the syllabus for training that there was a lot of calculations that you'd have to make. And, you would come across them over time, one at a time. In one section there'd be some calculation you'd have to make, in another section there would be. And so what I did was I decided to try to memorize them before I did my CPL written. So what I did was I would just copy all of the calculations that I had run across that I might have to perform during the CPL written on a single sheet of paper, which then I just pasted to the wall in my study area, and would sort of test myself to see if I remembered them. I made copies of that. I actually left it at Harv's air training school. I left it in the cabin where I was staying, and other people found it really useful to use. So at one point I took a photograph of it and made copies of it and would hand it out to my students. I've since lost that, so I decided a week or so ago that I would reproduce it in my book. So I did. And I'm going to provide it for those of you who are interested as a GIF in the comment section of YouTube and Facebook. So I'm not going to describe each calculation. I am going to, there they are, by the way, lots of them. Looks more complicated than it really is. But what I will do is I'll give you sort of an overview of what I have here on the sheet. And you can go ahead and look up the usage of said calculations. So it kind of runs the gamut of subjects in aviation. And so again, what I'm going to do is just tell you what's on this sheet, and you can go ahead and use that on your own if you like. If you're studying for your CPL written or your PPL written or your rec. So let's just start here. The very first one I have here, it's the weight shift calculation. So that's when you're calculating if you have to move baggage from one part of the aircraft to the other part of the aircraft. You can calculate the change in the center of gravity, the amount of weight that you need to move from what station to what station. So that's called the weight shift calculation. Small w over big W equals small d over big D, which is a quadratic equation. So that you will encounter many times in your aviation career. Another one that I have here, just a little one, is how to calculate the maneuvering speed. Maneuvering speed is the stall speed times 1.7. Very simple one. Beside that, I have the maximum crosswind component for an aircraft, Vs times decimal 2. And so that would be the crosswind component there. Beside that, I have what I call the VREF, and I did a video on that. That's the approach speed power off just before landing that you need to calculate for your CPL flight test. And so there it is, 1.3 times VSO times the square root of the landing weight divided by the gross weight. So that's in there to remind you. Another interesting one, I think this one's pretty cool, is how to calculate what the bank angle is for a standard rate turn. And that's knots true airspeed divided by 10 plus 7, or in miles per hour divided by 5 plus 7. Load factors. So the stall speed in a bank is based on the load factor. So that's the square root of the load times the stall speed. And then your load factors, depending on your bank angle, 0, 15 degrees, 45 degrees, and 60 degrees. So that's all there. How to calculate best glide speed. 1.4 times VSO. Best glide speed. Handy one to have. Here's one that is a little bit esoteric. What is the hydroplane speed in knots? It's the square root of your pounds per square inch of your tire pressure times 9. That's kind of cool. When you're doing tracking and timing and distances from VORs or NDB, we can do the time to the station, and we can do the distance to the station. And we can do that time in seconds times degrees change. So that's the time to station, and the distance is time in minutes times the true airspeed divided by 60. So that's that one right there. NDB positioning. People really struggle with NDB's ADF work. So just to remind you, magnetic heading plus relative bearing equals the bearing to station, right? And bearing from station is the bearing to station plus or minus 180 degrees. A little reminder there. Another handy one to remember is the VOR Dme Reception Range, which is 1.23 times the square root of the height you are AGL above the ground. So that one. One that you sometimes people forget is weight and balance. So weight times arm equals moment, and moment divided by weight equals arm. So that's there to remind you. You know, it's kind of handy, right? You can just sort of look this thing over and then try to recreate it on a blank sheet of paper and, as a memorizing tool. Now, one that confuses people quite a bit is cloud height calculations and freezing level in the cloud calculation. And it's a little bit tricky, but basically you need to work with the lapse rate of 2.5 degrees Celsius to calculate the base of the clouds per 1,000 feet. Now, those of you who have sharper edge, they have, in that section, they talk about Transport Canada using 3 degrees Celsius times 1,000 feet, which is wrong. Transport Canada is using 2.5 degrees per 1,000 feet. And it even says in sharper edge, like, caution, Transport Canada is using 3 degrees Celsius per 1,000 feet. Well, we researched that. Adam Penner from Harv's Air and I called Transport Canada, and it turns out that no, 2.5 is the number that they're using. But there is some confusion in the aviation world about which number to use. But hey, listen, if it doesn't work at 2.5, then try 3. If you get an answer that's in the answer section, then great. Otherwise, use 2.5. So basically, there's a very quick way to calculate the cloud base. It's sort of like a rule of thumb. You take the dew point and the temperature spread. So say the temperature is 10 and the dew point is 7, then the difference would be 3. And you multiply that by 400 to get your cloud base. The freezing level is a little bit trickier. All right, so it works in 2 parts. The freezing level, so there's part 1 and part 2. All right, you can look at this while you watch the video if you like. You take decimal 5 times the open bracket cloud base divided by 1,000 close bracket equals your new dew point, which you need to have. Then you take that new dew point, divide it by 1.5 times 1,000, and that'll give you freezing level. If the new dew point is below 0, then instead of dividing by 1.5, which is the saturated adiabatic lapse rate, use the dry adiabatic lapse rate, which is 3 degrees Celsius. So there's the cloud base and freezing level calculation. Okay. Here I just have, I'm just squeezing them in here anywhere I can. This one's called the estimated time of arrival rule of thumb. We use that for diversion. So if you're doing 90 knots indicated airspeed, then 2/3 of the distance that you need to go will be the time in minutes. Okay? And if you're going a little bit faster, just subtract a little bit of the time. If you're going a little bit slower, add a little bit of the time. But that's what I use when I'm teaching the diversions. Another cool one that I use for calculating while flying is when you're doing the precautionary, you need to estimate the field length, right? You do that on the high pass, but you can also do that on the low pass. And that's really cool because if you're set up like you're supposed to be with at 70 knots with 20 degrees of flaps, then each second that you fly over that field is worth 100 feet. So a little reminder there, measure field at 70 knots indicated, 100 feet is 1 second. So if it takes you 10 seconds to cross that field, to go along that field, then that's 1,000 feet. So that's kind of handy. I have a reminder of what the time zones are. Atlantic Standard Time is 60 degrees west. Eastern Standard Time is 75 degrees west. Central Standard Time is 90 degrees west. Mountain Standard Time is 105 degrees west. And Pacific Standard Time is 120 degrees west. Yeah, so track error, all right? So your opening angle and your closing angle. So your miles off the track divided by distance flown times 60 will give you your opening angle. And then your miles off track divided by distance to fly will give you times 60 will give you your closing angle. Add those two angles together and it'll take you directly to your destination. So that's it. That's quite a number of little calculations there. I hope you enjoy using that. I hope it's helpful for you. I know it helped me a lot, and some of my students really appreciate that, so much so that I have lost all copies that I originally had, which is good. That's a good thing. They should be in the hands of people who need them. Yeah, so that's my latest video from my Mayday flight tutoring page. And I know it's been a while since I made a video. I've been traveling a little bit in Germany, and I've got a few more coming up. I want to talk about constant speed propellers, because people get a little bit screwed up on the difference on how a constant speed propeller works and the difference between a single engine constant speed propeller and multi-engine configurations. A really cool subject to talk about is how exactly lift works, and this is kind of stolen from Rod Machado, M-A-C-H-A-D-O, Rod, R-O-D, Machado. He has a great video about that, so I may go over that at some point. A little bit more of an ambitious one that I worked on is navigation planning, how to set up a navlog properly so that you can do your navigation portion for your flight test error-free. So that talks about, you know, plotting your track, figuring out the winds aloft, figuring out your heading, climb fuel measurements or uses, taxi startup fuel. I mean, really it all comes down to like getting to where you want to go and not running out of fuel. So I may do a video on that. What else have I worked on here? Oh yeah, the wind correction triangle. A lot of people don't know that the E6B, the classic whiz-wheel E6B, is just a nifty way to calculate a wind triangle, which you can actually do by hand very easily with any straight edge. No problem. You don't even need a ruler, just a straight edge, a gradated straight edge. You can use millimeters or centimeters or whatever. Another area that people get a little bit messed up on is Pitot-Static systems and errors. So I wrote some notes on a video that I'll do on that. It's actually quite simple once you get the technique down of how to think of the logic of how Pitot-Static blockages affect the instruments. Yeah, so a little bit of NDB and VOR work that we may talk about at some point in the future. And one that I'd really like to talk about is altimetry. So altimeter settings, sea level pressure, altimeter settings, true altitude, absolute altitude, and even density altitude, so I can talk about that. And then I've also written some notes, which I haven't done videos on yet, are landing performance and takeoff performance. How you calculate these things and use the pilot operating handbook tables. So anyways, lots of good stuff in my little book here as I sit and have coffee and I write notes. And it keeps me fresh, keeps me thinking, and they're great topics to discuss quickly on the videos. And also when I'm sitting with students now, I have some notes that I can, you know, take a photo of and send it to them. It's helpful. Anyway, that's it for today. Have a good day.